So what is Albany about? It's a 300 millimeter research facility for doing cutting edge research, focus on new devices, new materials, new processes. Investment is collaborated and leveraged between a variety of entities, including in particular New York State and the University of Albany. And as I mentioned at the beginning, very, very strong focus, not on just research for research's sake, but on products and how do we develop the technology that can really deliver differentiated products for both us and our partners and our customers. Right away, we got major breakthroughs in Albany. We were the first demonstration of the use of immersion lithography, which is now used today in pretty much every technology. And then we developed the first smallest SRAM cell at the 22 nanometer ground rules. And then more recently, breakthroughs in FinFETs, the 3D devices I mentioned, an alternative fully depleted device, FDSOI, and then 3D integration. This is chip stacking. All of that work has gone on in Albany. But not by ourselves, as I mentioned, through collaboration. And you can see there's quite a range of partners here, process partners, equipment suppliers, material suppliers, Semitech, all working together to figure out how to advance the technology. So in summary for Albany, it's a fully capable facility that's unparalleled in the industry. This is not doing a little bit of research project here and there. It's doing fully integrated technology, research and development. And coming out of that, we have a technology which can go to IBM, to Global Foundries, to Samsung, to ST, and go into the development phase and go into manufacturing for our customers. It started at 200, expanded to 300. We had added an advanced packaging center focused on 3D integration. We just have a new building that's opened, EUV Center of Excellence, and increasing investment from our tooling suppliers. And we also announced last year the G450C consortium, so the research on how to get to 450 millimeter size wafers. So very well positioned to push the limits of scaling. But this is really just part of a total ecosystem. At the core is the technology development and manufacturing, but there's a whole ecosystem around it. Manufacturing, EDA suppliers, design IP solutions, and then a range of other aspects, packaging, advanced research, partnerships, that all go together to make this ecosystem work. And I think one other thing I want to highlight here, this investment in the Albany Nanotech Center just didn't happen. You know, it started with our investment in research in Yorktown Heights, Fishkill manufacturing facility, then a Burlington manufacturing facility, then we added a Bromont packaging facility, then came the Albany Nanotech Center, and then more recently, Global Foundries is built a big manufacturing facility in Malta, New York, which is just a little bit north of Albany. All of that's in that red circle, and this investment has built on itself and led to a high-tech research and development quarter in the Northeast, in addition to having our global presence. But it started with research and really expanded out. And so I want to talk a little bit about what does it take to build an ecosystem in the semiconductor industry. So I've kind of broken it out into where each person plays. So from a foundry perspective, it starts with that leadership, research and development, technology roadmap. Then it's manufacturing methodologies, control, yield methodologies. How do you ramp and yield the technology? And there's a whole methodology around that. And then the IT infrastructure to support all of that processing. You then have the design houses that develop the IP solutions, and then packaging and packaging assembly. We have that vertical stack of activities going on right here in Bangalore. In fact, we've had that focus. With my research and development team, we have an EDA team here, we have a custom logic team, we have a processor team, and we have a systems engineering team. And it's not by chance that we have all of those functions here. It's all focused on how do we co-optimize that entire stack to really deliver a differentiated solution. And there are a lot of the pieces already here in India. You know, there is the capability of getting technology. Certainly IBM has that. Expertise. You need to have that as a starting point and the design kits that go with it. But then you got to collaborate with that process development to get that total solution, as I mentioned. And that means the IP enablement, the design flows. There's already a very large infrastructure here in terms of design services and product development. And how do you co-optimize and integrate that entire function to really deliver the kind of products that are needed for differentiation in your marketplace. Let me just finish by saying a few things about what do I see are the advantages of a semiconductor manufacturing ecosystem. One which was touched on earlier in one of the previous talks was the export supply gap. The domestic electronic product demand is projected to be around 400 billion. It's expected about 100 billion of that would be spent here. That means 300 billion that's going somewhere else. Why is IBM? One of the reasons IBM is in their own semiconductor business is because we want security of supply, and we also want security that the technology and the design that we have is secure. And I think those are two key advantages that would be for India. National and information security and security of supply of semiconductor products. It provides a platform for really building on research and development talent. Job creation for us in the Northeast, I showed you that corridor. You can imagine with all of those facilities and all the supporting infrastructure, it's brought a tremendous number of jobs into the Northeast region. Some areas where I see as potential focus areas for India: set-top boxes, smartphones, tablets, smart meters, micro ATMs, basically a range of things in the consumer space and around that mobile drive. So in summary, technology advances will continue. It's going to require innovation. There's going to be new disruptive type technologies that will come into play. I highlighted a couple of them. Collaboration is required, not only for the financials, but also for really figuring out how to get the best value proposition out of the products. I talked about the ecosystem that we developed at Albany. And finally, I see semiconductor fabs as the centerpiece for such a broad design and manufacturing ecosystem. So thank you very much.
Let's all thank Dr. Gary Patton for starting the post-lunch session in a most fruitful manner. Before we leave him, I would request Mr. Ashok Chandak, the Executive Committee member, to kindly come over and present a memento. Thank you very much, Dr. Gary Patton. Thank you very much.